Hello everyone, welcome back to another Power Maths video. Today, I'll be going through the basics of complex numbers. Let's get right into it. First of all, what is a complex number? Well, first, you have to know what I is. I is used to denote the imaginary number. To recap, or to inform anyone who doesn't know, the imaginary number is I, which is the square root of -1. You may be thinking, how can you take the square root of a negative number? Well, you can't really, but since the mathematicians found the square root of negative numbers so useful, they started a concept around it, the imaginary numbers. So, if I is the square root of -1, then I squared will be -1. Keep that in mind, as it will be useful later on in the video. When using imaginary numbers and I is taken as a variable, so that means you can add a coefficient to it to get a multiple of I. And also, to clear any questions, the square root of -3 won't be 3i, but it will be I times root 3. Make sure you know that. On top of that, remember I is not positive nor negative, but a negative sign can be put on I to get a negative I. Isn't it weird? Now, let's move on to complex numbers. Complex numbers are written in the form a plus bi, with a and b being any number, but a cannot be 0. For example, 2 plus 3i and -7 take away 39i are both examples of complex numbers. So, we have learned what complex numbers are, but what do we do with them? First, let's learn how to add, subtract, multiply, and divide complex numbers. But let's start simple and start off with adding and subtracting. For addition, it's pretty simple. All you do is add the two real parts and the two imaginary parts together. For example, 5 plus 3i plus -7 take away 2i will give -2 plus I, because 5 take away 7 gives -2 and 3i take away 2i gives I. For subtracting, it's pretty much the same thing. Just subtract the real parts and the imaginary parts. For example, we will use the same numbers again but subtract them, and you'll get 12 plus 5i. Now, for multiplying, it's basically binomial expansion, so it's pretty simple. All we do is multiply the first term in the first complex number by both terms in the second complex number, and add the product of the second term in the first complex number to the two terms in the second complex number. Don't understand? Let me show you. 5 plus 3i multiplied by -7 take away 2i would be written as 5 times -7, which gives -35. Then 5 times -2i, which gives -10i. Then 3 times -7, which gives -21i. And now for 3i multiplied by -2i, we know that I times I gives -1, and 3 times -2 gives -6. So -6 times -1 gives +6. So the final answer is -29 take away 31i. Easy, right? Now for division, it's way more complicated. Division of complex numbers usually involves the multiple steps of multiplication to get the answer. Because this is an educational channel, I'll teach you anyway. But first, we have to learn what conjugates are. Suppose we have 6 plus 3i, and I need to find the conjugate of that. I'll simply flip the sign between the real and imaginary part. In this case, the conjugate of 6 plus 3i will be 6 take away 3i. And then another example will be -4 take away 9, where the conjugate will simply be -4 plus 9i. Got it? Now let's learn the division of complex numbers. Let's use the same numbers, 5 plus 3i, all divided by -7 take away 2. First, we're going to multiply the top and bottom by the conjugate of -7 take away 2i, which is -7 plus 2i. So on the top, by multiplication we learned previously, we'll get on top we get -41 take away 11i, and on the bottom we will simply get 53. So our answer is -41 take away 11i all divided by 53. It's not that hard, right? Now let's move on to the complex plane. First of all, you have to know what the Cartesian plane is. The Cartesian plane is a two-dimensional coordinate plane, just two axes, and the coordinates are written in the form x, y. But on the complex plane, the y-axis doesn't consist of 1, 2, 3, and 5, but it consists of I, 2i, 3i, 4i, 5i, and 6i. On top of that, instead of writing the coordinate as x, y, it is written in a complex form notation with x plus yi. Also, the labels of the axes changed from x and y to r and I for real numbers and imaginary numbers. Isn't it cool? Now let's see what happens when we add two complex numbers and plot them on the complex plane. Let's use 3 plus 4i and negative 2 take I. When we add them together, we'll get 1 plus 3. Let's draw lines from the origin to birth points, and then from 1 plus 3i to birth points. What shape does this form? This forms a parallelogram. This means that the inner angle at the origin is the same as the angle at 1 plus 3i. This can be used for many other things when you start complex analysis, which is currently way beyond my capabilities. Unfortunately though, there isn't anything exciting with the other operations of complex numbers on the complex plane. But there is still one last fact. Let's take a point, 3 plus 4i for example. Now, let's multiply that by I. Well, we know how to multiply by I, and we'll get 3i plus 4i squared, just 3i take away 4, which gives negative 4 plus 3i. So let's plot that. Now, do you spot anything? Probably not. But first, let me draw lines to the origin. Now, do you spot anything? The angle at the origin turns out to be a 90-degree angle. This is a well-known fact that if you multiply any complex number on the complex plane, you get a right angle. Unfortunately though, this brings us to the end of the video. I really appreciate you watching. Please like and subscribe as it helps a lot. In the next video, we'll be learning sigma notation, which looks like this. See you then!